Hi guys, for our final, Angela and I decided to research the chemistry of hair, including the chemical components that make up hair, how hair structure contributes to the physicality of hair, and how hair can be altered using dyes and heat. Okay, let's get started. The hair that sticks out from your head is referred to as the hair shaft. The hair shaft consists of three parts, including an outer, middle, and inner layer. The outermost layer is referred to as the cuticle. This layer is composed of exterior material made to protect the middle and inner layer of the hair shaft from heat damage and chemical damage. The middle layer is more commonly referred to as the cortex. This layer contains melanin and ovoid bodies, which determine the color and shape of your hair. Thus, since everyone has differently colored and differently shaped hair, there must be different types of melanin, which we will explain later. The innermost layer is referred to as the medulla. This part is part of the root of the hair, also known as the hair follicle, which anchors each hair into the skin of the scalp, thus keeping all of your hair from falling out.
The hair follicle determines whether the shape of the cuticle will be either circular or ovular, which in turn determines the shape of your hair. Your hair can take three general shapes: straight, curly, or wavy. If your hair cuticles are circular and even on all sides, then your hair will take a naturally straight shape. If your hair cuticles are ovular, then your hair will take a naturally curly or naturally wavy shape, depending on how elliptical the shape of the cuticles are. The more elliptical your cuticles are, the more curly your hair will be. People with curly or wavy hair do not have an even shape on all sides of the cuticle. At the base of the hair follicle is what is called the hair bulb. Inside the bulb are cells that undergo the process of mitotic cell division and build the hair shaft. The hair shaft is composed of keratin and melanin proteins that give your hair the color and its shape, as well as small amounts of metallic elements that are present in your hair. This picture shows what a hair follicle looks like underneath a microscope. As you can see, there is a clear division between the hair shaft and the beginning of what we refer to as hair. The arrow points to this point where the shaft turns into actual hair.
This diagram shows a basic overview of the structure of the hair follicle in the skin. As discussed earlier, here you can see how the hair bulb forms into the hair shaft, which then turns into hair outside of the head. Melanin is a pigment that gives human skin, hair, and eyes their color. The type of melanin in your hair is the same throughout, which is why hair is a uniform color and people don't have half blonde, half black hair. Melanin is made in the hair bulb by melanocytes and then given to keratinocytes, which produce keratin. Melanin makes up a total of 1% of your hair. There are two types of melanin that in different amounts produce slightly different hair colors. Eumelanin, when present in the hair, gives hair either a brown, red, or black color. Conversely, pheomelanin, when present in hair, gives hair either a blonde to red color depending on the amount of pheomelanin in the hair.
This diagram shows the chemical structure of melanin and the various bonds present in the chemical. Hair is primarily composed of three bonds: hydrogen bonds, salt bonds, and disulfide bonds. Hydrogen bonds in hair are abundant and weak and play an active role in the shape of your hair. Whenever you style your hair or take a shower, you are actually breaking the hydrogen bonds in your hair and changing the physical shape of your hair. When your hair cools down after styling, these hydrogen bonds reform, which is why curls sometimes fall out of your hair. In addition, when you dry your hair after taking a shower, the hydrogen bonds in your hair reform, which causes your hair to revert back to its natural shape. Salt bonds in your hair are broken by an acidic solution or a drastic change in pH. Bleaching your hair using some form of bleach, such as hydrogen peroxide, which is what we used in our experiment, breaks the salt bonds in your hair. These bonds are reformed when the pH of your hair is brought back to normal. The last type of bond that your hair is composed of are disulfide bonds. Disulfide bonds are not broken by heat and water and are less abundant than salt and hydrogen bonds. These bonds give hair its strength and its durability.
To recap, your hair shaft is composed of keratin and melanin, which give your hair its shape and color. Keratin proteins are held by hydrogen bonds and maintain the natural shape of your hair. The two ways to modify the natural shape of your hair is through water and heat. Bonds are modified in hair and rearranges the hair before the bonds return to their original position, which is why curling and straightening your hair is not permanent. Temporary heat styling only alters the physical bonds between weak hydrogen bonds in your hair, which reform when the hair is cooled. The consistent use of heat to style your hair eventually will lead to long-term damage of the follicle and hair shaft. Using heat daily on your hair creates cracks in the outermost protective layer of your hair and leads to the degradation of the cortex layer. High temperatures applied to your hair throughout heat styling create steam that gets trapped in hair and leads to the loss of the protective cuticle layer of your hair. Hair is primarily made of protein, and thus maintaining a healthy diet rich in protein helps to keep your hair healthy even when undergoing heat treatment.
This diagram shows the difference between the cortex and the cuticle of healthy and damaged hair. The cortex in the damaged hair has obviously undergone degradation and is not smooth and put together as shown in the healthy hair. The cuticle in the damaged hair has formed cracks which cause the protective layer to break apart and not stay together and protect the cortex as shown in the healthy hair.
Although temporary heat styling is more common, there are certain ways that you can permanently change the shape of your hair. In order to permanently change the shape of your hair, you must break the chemical bonds in your hair. This is done through breaking and reforming disulfide bonds through reduction. Thiol compounds are added to add hydrogen atoms to the sulfur atoms to break disulfide bonds. Polypeptide chains are permed or straightened, and the broken disulfide bonds are treated with hydrogen peroxide. This removes the hydrogen atoms from the hair and reforms the disulfide bonds through oxidation and results in a new shape of the hair which is permanent.
These are real-life pictures of what natural hair looks like, both damaged and healthy. As you can see, the damaged hair looks more shaggy and unhealthy with no shine. The healthy hair is kept together and possesses a healthy shine to it. When lightening hair, bleach oxidizes the melanin in the hair. This molecule is colorless. However, bleached hair turns out as a pale yellow as a result of the natural color of keratin. Bleach reacts more readily with eumelanin than the pheomelanin, which is why it is often harder to bleach already blonde or red hair than it is to bleach hair that is dark brown or black. Usually, hydrogen peroxide is used as the form of bleach. Just as the shape of your hair can be permanently changed, the color of your hair can be too. In order to do this, the hair cuticle must be open and permanent dye must be deposited into the cuticle. Ammonia is used for this and is a catalyst in the process of dye reacting with the cortex to deposit or remove hair color. Hydrogen peroxide is used as an oxidizing agent to break chemical bonds in the hair, release oxygen, release sulfur, and remove pre-existing color in hair. Hairstylists will often bleach hair before dyeing it a different color in order to start with a clean slate. The sulfur present in hair color explains the unpleasant smell of hair dyes.
The process of permanently changing your hair colors occurs in 2 steps. However, these steps occur simultaneously. These steps include the removal of color and the deposit of new color. You can think of the process like a Ferris wheel. As people leave the Ferris wheel, new people are allowed on, and the ride continues. Instead of filling the Ferris wheel and then getting everyone off and then allowing new people on, the 2 steps occur simultaneously. This is the same process that hair undergoes when it is lightened. However, a colorant is added to the hair shaft. Special conditioners are made for colored hair that are especially designed to close the cuticle after coloring in order to seal in and protect the new color. In order to demonstrate the concepts that had been discussed about the chemistry of hair, 2 experiments were conducted. In the first experiment, hydrogen peroxide was used to lighten the hair of Emma. The materials used include 3% hydrogen peroxide, cotton balls, gloves, aluminum foil, a fine-tooth comb, a hair dryer, an empty spray bottle, and Emma. The experiment was conducted by initially dampening the hair of Emma and combing it out. Next, cotton balls were soaked in 3% hydrogen peroxide and used to saturate the ends of Emma's hair. A towel was wrapped around Emma's hair, and aluminum foil was wrapped around the experimental section of Emma's hair to hold the cotton balls in Emma's hair, as the hydrogen peroxide was given 20 minutes for absorption. After 20 minutes, the aluminum foil and soaked cotton balls were removed and Emma's hair was washed and dried.
The results of the experiment indicated a noticeable change in hair color of Emma. The bleached part of Emma's hair was noticeably lighter, and the experiment was presumed to be successful. Once the hair was saturated with hydrogen peroxide, the compound entered the hair shaft and released oxygen in a redox reaction, causing the natural pigments of Emma's hair to be removed and ultimately causing Emma's hair to appear lighter than natural. Although the experiment was successful, it could have been improved by leaving the hydrogen peroxide in Emma's hair for slightly longer in order to produce more dramatic results, although this was not necessary. Now we'll show you before and after pictures of Emma's hair during the experiment.
I'm one of the greatest to ever do it. Lucifer. Where you from? Going on. Oh, sauce it down, sauce it up. You too much, ain't enough. Where you from? Throw it out. Going nuts, yeah, going down. Oh, sauce it down, sauce it up. You too much, ain't enough. Where you from? Throw it out. Going nuts, yeah, going down. Every day I'm ballin', so you know it's scoring.
A final demonstration in the concepts of the chemistry of hair was performed by simply curling Emma's hair. By using a curling iron to curl Emma's hair, the concept of how heat styling is able to temporarily change the shape of Emma's hair was manifested. The only materials needed to showcase this were a curling iron and a strip of hair. The procedure began by preheating the curling iron to approximately 450 degrees Fahrenheit. Once the iron was warm enough, the hair was wrapped around it and held in place for approximately 40 seconds, then released.
Once the hair was released from the iron, it was held in the shape of a curl until disturbed by water, steam, or another heat product. In this case, it was water. What happened during this procedure was that the physical bonds between hydrogen molecules in the hair shaft were modified by the excessive heat provided by the curling iron to hold the shape that the curling iron provided. This demonstration was also successful, for the shape of the curl held firmly until altered by water, which happened when Emma's hair was put under running water in the sink. When this happened, the hydrogen bonds in Emma's hair were re-established because of the water, and the curl lost its shape and reverted back to its natural shape.
JP Sounds.
Thank you for watching our video about the chemistry of hair. We hope you learned a lot. Everything is fair game.